back to the layered model. There is a reason why we do that, or there are many reasons why we choose to put things in layers. First of all, it's because all these different functionality could be very difficult to comprehend because it's so complex. So it's easier for us if we try to put them into layers. So different functionalities will be placed in layers, and then we can change something within the layer as long as we don't change anything that will take care of the information from one layer to another. So making changes is also easier when we are using a layered model. And the whole idea of understanding what's going on. So what we do is that if we take it from the bottom, then we have the cables where the actual communication is done, and then on top, the top layer is where you sit with your computers. And all these different things that we need to take care of, all the rules that we need to apply, is taken care of down within the model. You can see here that if we compare TCP/IP to OSI model, then that the whole application layer in TCP/IP will cover the three topmost layers in OSI, which is application, presentation, and session. Then we have the transport layer, which is the same, and the internet or the network layer, which is the same. And then the two last layers in the OSI model is put into one layer in the TCP/IP model, which is the network access. I tend to put the wrong key here. Okay, so let's have a look at the OSI model. We have on the bottom layer the physical layer. This is the cables, and what kind of if we're sending data on a copper cable, how will we modulate the voltage? If we send it on the fiber cables, how will we put in the lights or the intensities of lights? What is a 0 and what is a 1? Because everything down here are zeros and ones, the binary traffic. So it's either on and off. So this is quite simple to modulate in physics. Whether we're sending it as light or voltage or just sending radio waves into the air. This is just modulating in on and offs or zeros and ones. The data link layer will take care of flow control, and it will take care of the physical addresses, which when we talk about networking is something called the MAC address. MAC address is something that all networking devices has, and it's actually something that they are born with when you get them. You don't really change that address. But on a local area network, that is the address that's important. That is the one we use when we are sending something from one device to another. If we want to enhance and send something out to different networks, then we need the networking layer address, which is the logical address, or in our world, it's the IP address, which takes care of sending out between different networks. Then we have the transport layer, which will make sure that when the communication or the data is received at a host, then the transport layer will first of all check that everything is there, that everything is taken care of correctly, and it will also send it to the correct application. If this data is web, it's HTTP traffic, then it will send it to our web browser. If it's mail, then it will send it to our mail client. So it will look into the data and see what kind of data is this, and then it will send it to the correct application. And then the application layer here is the gateway to the rest of the applications on our computers and servers or whatever devices. So it will be handled by the different applications taking care of, for instance, mail or FTP for sending and receiving files. The presentation layer and the session layer is something which is only a part of the OSI model. It's not something that's really implemented in TCP/IP, for instance. Presentation is thought to be the layer if you want to change between different kinds of file types. If I send something as a BMP file to you, but you really would like to have it in JPEG instead, well, then the presentation layer could change that between different file types. It could also be where I could add on data compression if I want to compress my data, or if I want to encrypt it, for instance. It could also be done on the presentation layer. But this is too heavy. It will take too long time if my networking model should take care of that. So we don't really use that in real life. The session layer is thought about keeping track of all the sessions that I'm running on my computer, not on my computer, but with the network, so that if something goes wrong in my data communication, well, then it could pick up where it left instead of just starting all over again. And there are some protocols in TCP/IP that takes care of that, for instance. But the whole idea was that there should be a layer itself that took care of that. Yep. But as I said, this is a reference model. It's not a model you will see out in real life. But it's something that we always reference when we are talking about, using as a reference when we are talking about networking. Yes. So the overall 4 layers of TCP/IP, you can see if we start at the top, we have the application layer where it represents data to the user and coding and use dialog control. So these are all the applications that are available to the user and to the applications. The transport support the transportation between devices and the end devices, and so that it makes sure that the device, or not the device, but that the data will reach the correct application, for instance. The internet layer determines the best path through the entire network, and the network access will control the hardware of it all, both the access to the hardware, but also the different types of cables that we want to send things on. Yes, and we have compared it. So when we are going to send something over the network, well, then we are chopping it up into smaller parts, which is the size of the data that can be put into each data packet, and then we will encapsulate it through the different protocols. For instance, here I'm going to send something, an email, for instance. Well, I'll start in my email program, and I have my email as a long set of data. And then my networking protocol will chop it up into smaller parts. And each of these parts, which is called a PDU, it's a protocol data unit. It is sent down to the transport layer. The data is on the application layer, and then the segment is on the transport layer, and this one will get a transport layer header. For instance, setting the port numbers. What kind of an application has sent this? Well, this was an email, so it is the SMTP protocol that has sent that, and that has a certain number. So it's the address for the type of data that I'm sending. Then my transport header and the data is moved down to the internet layer, where it's now called a packet, because now my data is put on, well, I put on another header. In this case, it's the networking header, where we put on, for instance, the source and the destination IP address, where it will be sent to and from whom it was sent. And then, depending on what kind of a media, whether it's a cable network or a wireless network, it is sent down to the physical layer, and we're putting on new headers there as well. Typically, if we are sending it out on a LAN, an Ethernet LAN, well, then it gets both a header which is a frame header. It's called a frame at this point, and it has a frame header in the end as well, or a trailer, which just tells us that now this is the end of the packet. And then everything is encapsulated into binary information, which is just a bunch of zeros and one. And when it's received in the other end of the communication, well, then it's de-encapsulated again, so that it will look at the binaries, put it up to the network access layer, look at the frame header to see, okay, is this my packet? Because here we have the physical address. If it's okay, then it's sent up to the internetwork. It will look at the networking header, look at the IP address. Is this me? Yeah, it is. Well, then it's sent up to the transport layer, where the transport layer will look at the transport header and see, okay, this is mail. Then it will be sent up to the mail program. So it's unencapsulated again when it's received. Yeah. So altogether, we receive, for instance, on a web server, a much larger packet than the actual data within it, because we need to add on all these headers to be able to send the traffic from one device to another. Yeah, de-encapsulation it is called when it's unpacked again. Yeah, so we need to make sure that these different layers have different functionality. The physical layer, which is the cabling, will do the synchronization of bits. We need to know when to stop listening for zeros and ones, for instance, and the timing here. The physical addresses is placed on the data link layer. The logical and the whole finding the best path is on the network layer. The transport layer will put the port number on the source process number, and the upper layer will take the encoding and how will the data be presented into the different types of applications and protocols that we need. Yeah, when we are communicating over the same network, then we are using the data link header, which is the physical address. The physical address is the MAC address, and it's only valid within the same network because we cannot see anything else from it than just a number. In this case here, it's just a bunch of A's and C's, for instance, and this is what a MAC address is. It's just a bunch of numbers. It's 48 bits altogether, so 48 zeros and ones. And we cannot really read anything else from it, and it's just a unique number for each and every device. When we want to send data onto other networks, we need to have an address that can give us more information of which network this device or this data is going to be sent to. So this is why we add the IP address on the network layer, where we get an idea of which network do we want to send it from. So there we can put up look into our routing table and see how do I get to this network, and then it is sent on to that. So on different networks we need at least an IP address, or on the same network we can just use the MAC address. But as I told you, we are still using TCP/IP on our local network as well. So we need to have some kind of a link between a MAC address and a IP address. And everything on these devices here in the lab, but on all networks, you have an IP address, and the IP address is known. So if I want to send something to one of the computers over here, I just I know the IP address, and then I can send it to the device. But since on a local area network, they're actually using the MAC address instead, we need to have some kind of a translation between MAC addresses and IP address. And for that use, we have the ARP protocol. The ARP protocol will take care of the transformation from IP address to MAC address. So if I want to communicate with a computer in here, and I've never done it before, I've never communicated with this device before, so I actually don't know the IP or the MAC addresses of it. So my computer will send out a ARP request asking this IP address, who has what kind of a MAC address correspond to that, and it will be sent out as a broadcast to all the devices in the network in here, and then the device with the correct MAC address will, or the correct IP address, will answer back, well, that's my, and then I get it, and my computer will put it into its ARP table, so the